Hey everyone, this is video 257. We're going to go over right-hand rule number 3. The purpose of this rule is to find the direction of the magnetic field due to a current carrying loop. So this rule is actually the opposite of right-hand rule number 2. If you remember right-hand rule number 2, we had a straight wire carrying a current. We put our thumb in the direction of that current, and then our fingers looped around the direction of the magnetic field. So in this case, the fingers would loop around this way, and that would be the magnetic field. So the thumb was the current, and as I told you back then, I was like, you can remember that because the thumb is straight and the current is straight, right? So thumb was the straight current, the straight wire, and then the fingers curling, that was the magnetic field, because the magnetic field produces loops around that straight wire. So now, right-hand rule number 3, we have a loop of wire carrying current. So now the current is curling. Well, what can curl is your fingers, right? Your thumb can't curl. So that means your fingers are going to be curling in the direction of the current. And then the thumb is going to be the magnetic field, because the magnetic field is straight and your thumb can only be straight. So that's the best way to remember that I can think of. So in this case, we have this loop here, and in this case, the current is going counterclockwise. So my fingers right here are looped counterclockwise. If I'm looking at them from my perspective, is counterclockwise, and the thumb is pointing straight at me out of the page. And that's what you can see for the magnetic field. A dot means it's going out of the page. So that's right-hand rule number 3. I do have the second step here. I just knew that it would erase all of my drawings. So fingers curl in the direction of the current, and the thumb points in the direction of the field. Let's go ahead and do one example using right-hand rule number 3. The following diagram shows a slice through a current loop perpendicular to the page. The direction of the current in the wire is shown. What's the direction of the magnetic field at a point in the center of the loop? So what we're seeing here is we're seeing a loop of wire that has been cut in half so that we can see which way the current goes. The current goes out of the page at the top, and it goes into the page at the bottom here. So what you want to do is use right-hand rule number 3 to figure out the direction of the field. Hopefully you've paused the video. Let's take a look. The first step is to curl your fingers in the direction of the current. So you want to have your fingers curling this way, because if you curl them this way, where your fingertips are in the front, then you can see at the top, the current is coming towards you out of the page, but then at the bottom, when you're curling, you're going into the page here. And that's exactly what the cross section, that slice, is showing. When your fingers are curling this way, you're going into the page at the bottom and out of the page at the top. Which way is your thumb pointing? In the direction of the magnetic field. So the magnetic field points to the right at this location in the center of the loop. So that is our answer. And that's all for the right-hand rules. So definitely practice all 3 rules so that you don't get them confused, and hopefully they help you in finding the directions that are asked for in the problem. See you soon.